Thank you for joining me for this tutorial on KnitScript, a programming language for automatic knitting machines. I'm Megan Hoffman from the Corey Accessible Creative Technologies Lab, or the ACT Lab, at Northeastern University. And this was recorded in October of 2023, so some of the details of the KnitScript language might have changed by the time you're viewing this. Let's start with talking a little bit about how knitting works. Imagine you have a loop of yarn, like this white loop here, and you were to try and pull either end of it. The loop is going to become unstable, and you no longer have a loop of yarn. But if you pull another loop through it, you're stabilizing that loop of yarn and making a knit stitch. If you make a bunch of these knit stitches, stabilizing many loops of the same yarn, you're going to create a knitted texture or a piece of fabric. And you can change the structure of this fabric by deciding which direction you pull the loops, either from back to front or front to back. And if you do this over a variety of different patterns, you can control the physical properties of your fabric. So let's talk about how we might go about programming in these physical properties using an automatic knitting machine. KnitScript is a language that is going to help you by detecting and preventing common knitting errors, allow you to import common knitting procedures, and import your own Python code or from other Python libraries so that you can do some algorithmic parts of your knitting. So for example, we can import cast-ons to align our stitches and get our stitches started up. And we can import things like the random library from Python to help us make stochastic decisions. And we can use common variables and parameters, just like in any programming language, to help us go through this process in an algorithmic way. We can also specify some properties that are specific to the machine, such as which yarn carrier is being used when we're knitting, or look at the state of the knitting machine, looking for which needles currently hold loops or what direction the machine is going to move in next. And of course, like any other programming language, we can use common control structures like for loops and if statements. But we also have some control structures that are specific to knitting and carriage passes, so that we're always keeping track of what we can do on the machine. So let's talk a little bit about how a knitting machine works and how we might control it. The first thing you need to know for a specifically V-bed machine is that you have a bed of needles and you have a front and back bed that are aligned. The front bed is going to make knit stitches, if you're a hand knitter, where you're pulling loops from back to front. And the back bed, conversely, is going to make what a hand knitter would call a purl stitch or a back knit, which is a knit stitch that is pulled from front to back. Now, in order to make all of those stitches, we're going to need to move yarn around, and we do that by using the yarn carriers. You can think of these as syringes or extruders, if you're coming from a 3D printing sense, that are going to provide all of the yarn you need. Each individual carrier is going to hold one yarn, so that's how you do different colors. And then finally, we have the carriage, which is going to move leftward and rightward across the machine, actuating all of the needles in what we call a carriage pass. Now, because this is a physical object, if it's on the right side, it's going to have to move leftward, and if it's on the left side, it's going to have to move rightward. So keeping track of where your carriage is one of the main challenges of machine knitting, and KnitScript's going to help you do that. Now let's start with the most basic operation on the machine, miss. This is going to move an active carrier to a specified needle position in a specific direction. Because the yarns are connected to the machine when you're knitting, the direction matters here. Anytime you're using a yarn, you're going to have to tell the machine which direction to move. So in this case, the KnitScript says, with carrier as 1, which sets it to the active carrier, in a leftward direction, miss on F6, which is going to bring a carrier from the right side to the left side and move it to F6. Now, let's start using those yarns. And the most basic operation we can do to use the yarn is called a tuck. This is going to place a loop of yarn on a specific needle in a specified direction. So in this case, you can see a loop being added onto a needle that is already holding one loop, making 2 loops stacked on it. So to specify a variety of tucks, we would say in KnitScript, in a leftward direction, or rightward if you wanted to, tuck from F2, F3, F4, and F5. Now you'll notice that F2 through F5 are ordered from a rightward direction, but that doesn't matter. KnitScript is smart enough to resort those for us so that we don't have to keep track of sorting our needles ourselves. It's going to do them in the direction you specify in the statement. So it's going to pull the carriage over to the right side and start knitting F5, F4, F3, and F2. Now remember that you're going to have to move the carriage to the side that it needs to start on. So in this case, it added a little no-op carriage pass for us. You don't have to do this. It's always going to do it for you. If we want to start building up the fabric, we're going to need to knit, which is pulling a loop of yarn through the loops on a specified needle in a specified direction. Again, we're using a specific yarn, the active carrier, and so we have to specify a direction when we're knitting. So in this case, we might want to knit on all of the front loops, in this case F2 through F5, which currently hold loops from our tuck pass. And this time we're going to move in a rightward direction. The carriage and the carrier are already on the right side, so this is just going to do it in one smooth pass. Knitting F2, F3, F4, and F5. But what if we want to move loops around and rearrange things a little bit without knitting or tucking? The way we do that is called a transfer, or often abbreviated to exfer. This moves the loops on a specific needle to the opposite bed. So if we wanted to move the loops on F3 and F5 onto the back bed, we would tell them to transfer across. There's 8 and 6 moving to the back bed. In KnitScript, you can often specify which bed you want to move things to. So if you're specifying a bunch of loops all at once, some of which are already on the front bed or the target bed, then they're not going to be moved. But the ones that are on the back bed are going to be moved to the front bed. You would say this by saying exfer B3 and F4 across to the front bed. There's B3 moving, but F4 doesn't do anything because it's already on the front bed. But what if you want to move things around laterally? Well, to do that, you're going to need to rack. Racking is realigning the beds at different directions. And you can remember this with a few different equations that allow you to figure out the racking value. The first is that if you have a front needle, you can align it to a back needle plus the rack value. If you have a back needle, you can align it to the front bed value minus the rack value. And you can specify the rack value as the front bed minus the back bed needle you want it aligned with. So let's start by racking 1. This shifts B5 to be aligned with F4. We can also rack to 0, which will realign everything back to the standard racking. And notice that the loops in the back bed are always being moved in this case. So here we're realigning so that F5 and B5 are aligned, and that loop number 8 is being moved directly. And then finally, in KnitScript, if you don't like keeping track of positive and negative integers for direction, you can specify the direction you want to rack in. So in this case, we're going to say racked 1 to the right, which is going to bring bit B5 to be aligned with F6, 1 to the right of itself. And there we can see that change. This allows us to realign loops and move them around for different types of transfers. And this brings us to one of our final operations, the split stitch. What a split stitch is going to do is pull new loops through the loops on a specified needle while transferring the old loops to the opposite needle. You can use this to create increases and such. This operates in a specified direction, like knits and tucks, because it is using a loop of yarn, but it does have the caveat that you can't combine it with other operations like knit and tuck. So here we split, and then we can knit afterwards. But in order to do this, we would need to specify 2 different passes. First, we can say in a leftward direction, split B5, which is going to move leftward and split across. And then we can say in the current direction, which is going to be leftward, we're going to knit on the front needles between 2 and 5. So this is going to allow us to do 2 kind of simultaneous carriage passes in the same direction, making that nice, smooth motion here. Now, let's say you want to do a bunch of transfers and you want to rack at the same time, but you don't want to keep track of the racking separately. Well, we can do that in KnitScript by telling it which direction we want to transfer to. So in this case, we can say transfer B5 1 to the left across, which is going to move any loops on B5 1 leftward and across to the front bed. There's the rack that happens between, and then the carriage pass that is going to allow us to do that transfer. And then finally, what if we want to work with multiple yarns? We've been working with carrier 1 since the beginning, but we can specify other carriers. Carriers in KnitScript are specified by a value starting with the letter C, followed by a number, up to n, usually 10 if you're working on a Shimaseki machine. And you can also use integers to set these. They'll automatically be cast to carriers. You can set the value of the carrier value, and then all subsequent knitting until you change that will be using that as the active carrier. And in order to do that, we set the carrier as carrier 2, and then in this case, knit between F2 and F6. Like carrier, there are a bunch of useful variables in the knit script language that will always keep track of the machine state for you. So for example, for keeping track of needles, you can say front needles or back needles. These will give you the set of needles on the front and back bed ordered from left to right. But you can also say loops, which is the set of all needles that are currently holding loops. This is ordered with the front needles that hold loops left to right, and then the back needles from left to right. You can also specify front loops and back loops if you just want the subset on either bed. And you can access the last pass, which is going to give you the set of needles used in the last carriage pass ordered by when they were activated. In the case of a transfer, this is going to give you key value pairs, where the key is the starting needle, the needle that was holding a loop, and the value is the ending needle, the needle that ultimately ordered the loop after the transfer. You can also keep track of parts of the machine, such as which is the active carrier, the current racking value of the machine, the current direction the machine just moved in. So if you want to continue a pass like we did with the split, you could use current, and reverse, which is the opposite direction the machine moved in. In the case of current and reverse, these are always going to be directions based off of the last direction you specified in your code, rather than the directions that happen because of transfers. Whenever you do a transfer pass, it will make sure to add a no-op if it's necessary to move it back to the same position. You don't have to keep track of those different transfer passes. Together to do some common knitting patterns. The first are cast-ons, which help you establish your first set of loops or your first course of knitting. There are two common ones, such as the alt-tuck cast-on, which is an alternating tuck pattern that you can do on the front or back bed, allowing you to cast on to a single side of the machine. The second one is an all-needle cast-on, which is an alternating tuck pattern across both beds, which allows you to establish loops on both sides. So let's look at that front alternating cast-on. First, we're going to move in a leftward direction, tucking on the every other front needle, and then we're going to remove in the reverse direction, tucking on the remaining needles, in this case, the odd needles. So on a value of 4, we start on F2 and F0, and then we come back knitting on F1 and F3. This is a more stable pattern for casting on than if we had knit directly across it. For a large number of needles, if you knit directly across, the yarn tends to slip out, and this causes a lot of trouble. Next, for an all needle cast on, we are able to tuck on the front and back needles all at once. So in a leftward direction, we knit in this particular order. Because they're alternating across the front and back beds, this is a more stable feed. Now that we've established our cast-ons, let's look at some common knit and purl patterns. This will allow you to create textures that are bumpy and stretchy and stiffen your fabric in different ways. The most common or basically canonical knitted structure is called a jersey stitch, or if you're a hand knitter, you might know this as stockinette. And the way you can do this is by doing a reverse direction pattern where you always knit on the front loops. So in this case, we're just knitting across the front bed. We can also create tubes using a knitting machine by knitting across the front bed and then knitting back across the back bed. And if we repeat this pattern, it will create a tube-like structure. So there we knit across the front, and then we knit across the back. Another common structure you'll see in knitting is called a knit purl rib, which has alternating knit and purl stitches made by knitting on the front and back beds. Here we show a half gauge knit purl rib where we're knitting every other needle on the front and back. We can use that same knit purl pattern for ribbing to create a seed stitch, which is a checkered pattern where we knit two different courses, alternating which section is ribbed. So in this case, we're going to start by knitting our rib pattern like last time, but then we're going to transfer the loops across so that we're starting a new pattern. And then finally, we add our next row of stitches. Notice that the carriage was automatically moved back to where our carrier was to allow us to move in the reverse direction. But what if we want to start making more complicated structures and shaping things? We can make shapes and laces and other types of patterns by doing increases and decreases. An increase is created by shifting loops away from one needle so that you can create space to tuck on it in the next pass. So in this case, we're going to start with 3 different needles. And we're going to shift them to the back bed, rack them over, and then knit again, tucking on that extra space that was created for us. So we transfer loops across to the back bed, move the back loops over to the left, and then knit on the remaining loops and tuck on F2. We could use a similar pattern to create a decrease or reduce the number of loops, transferring to the opposite bed and then moving the needles over, shifting them to create a decrease. So in this example, we're again going to transfer our loops across the back bed, transfer the back loops across to the right this time, overlapping them, and then knit on them to create a decrease structure. Here we see the move from over, across, and back down. And then we knit across using the carriage pass in the direction that we specify. Back to that original piece of code and put this all together. Starting off with importing our alternating tuck cast-on from the library. This is a standard library provided with KnitScript with some useful features, and we intend to expand on it greatly in the future. So here it's going to do all alternating tuck cast-on for us of a width specified, and the alternating tuck cast-on is going to add a convenient extra row of knit stitches. This essentially stabilizes our cast-on for us, and you can change this as a parameter, but it defaults to adding one extra course. Next, we can do some algorithmic code. We can set a variable, which is the list of transfers we want to make, and then look at all of the active loops and randomly decide which ones we want to transfer. This is going to create a randomized knit purl pattern. So we've, in this case, selected to transfer F1 and F2. Then we transfer the transfers across, moving them over to the back bed. And now when we knit, we're going to knit a variety of knit and purl stitches, depending on where the loops are. Pay attention here that we're using the loops variable in the code so that we don't have to remember where everything has been transferred to. We move that carriage to align with our pass, and then we knit across. And we would repeat this structure for many for loops over many iterations so that we can build up a complex fabric. I hope that this brief tutorial encourages you to explore some algorithmic knitting and use KnitScript. This work is funded and supported by the NSF and has been completed by a team of researchers at the Corey College of Computer Sciences at Northeastern University. And if you want to get a hold of this, you can find our stable distribution on PyPy, our source and documentation on GitHub, and a publication of the original research from WIS 2023. And you can also find out more about what we're doing with KnitScript and other knitting tools at the Corey Act Lab at Northeastern. Thank you for your time.